Carlos Lafita. Carlos Lafita is a PhD in Chemical, Environmental and Process Engineering by Escuela Superior de Ingeniería de la Universidad de Valencia. His PhD thesis topic was related with the development of biological treatment technologies for the removal of VOC in industrial air emissions. He worked for a Dutch engineering that designs and constructs biological reactors for air treatment, and currently he is in the R&D department of the wastewater treatment section in Global Omnium Medio Ambiente, implementing new technologies for air remediation, anaerobic digestion processes, and emergent pollutant measuring and removal. Please, Carlos.
Thanks for your presentations, Laura. First, I would like to say that this work was possible because of the collaboration of two public entities, Technical University of Valencia, and also University of Heidelberg, and also a private company, Global Omnium. Well, here you can see the content of the presentation, and now we're going to go through the introduction just to put it in context, the work. After 2 days of presentations, all of us know that nowadays we have an increasing concern about odors in complaints, mainly because of the wastewater treatment plant, sorry. And despite that there is no specific laws, sorry, there's no specific laws in Spain at national level. We have some data about complaints in the country. This data you can see on your left that is mainly focused in some places, mainly probably in the south. This data was done by the National Statistics Organisms. I think that it was in the past, not currently done any more discussions in the population and housing census. But even though we have this data, probably nowadays is worse than in 2001. Also, we have some data about the complaints due to the water sanitation. Main part of the complaints are done in populations higher than 10,000 inhabitants. The non-mitigation of other complaints or the result of the non-mitigation of these other complaints is these complaints and this reference in newspapers. I think this is already said during these days that the main part of odors in wastewater treatment plants are caused by S2S, ammonia, and organic compounds. The main part of S2S is produced in the pre-works or pre-treatment of the wastewater arriving to the facilities, and this is the main compound that causes odor annoyance. This is because we have a very low threshold. This is about 5 ppbs. The effect of odors the odors have effect in both on health because it causes stress, anxiety, and irrational attitude, and also cause a poor image of facility managers. So, because of this, we have to find a solution of to mitigate these odors, and this solution has to be ad hoc for each facility. One tool to do this ad hoc solution is the use of models. In the case of this work, we have used AirMod model. This is a Gaussian steady state model plume. This model enables to the diagnosis and prediction in complex terrain and is useful for winds flow higher than 0.28 meters per second. The main objective of this work was to determine whether or not mitigation measures are necessary to protect adjacent dwellings from odors. The secondary objectives or the objectives to be achieved to achieve this main objective were the identification of odors, compounds, and the sources of these odors compounds. Also, do the correlation between the odor or the compound found and the annoyance from a neighborhood. The implementation of mitigation actions and bear out the algorithms done in the wastewater treatment plant to mitigate these odor emissions. First, I would like to describe more or less the wastewater treatment plant we have worked. This was close to the sea, more or less about 300 meters, and very close to the houses. only 14 meters. This waste treatment plant was smaller, quite small, because it was treating about 300 meters per day of wastewater, and it was composed by only one bioreactor of 20 meters diameter, one settled tank of 12 meters diameter, and 7 drying basins that were operated during summer, from June to September. For the measuring of odor, we have used two different ways. One was field of optometry. We have used NASA Ranger. This, I don't know if people know this device, but we have dilutions, and we have panels that are calibrated, and depending on the calibration, we can achieve one or other concentration. In our case, we were working between 2.5 and 70 odor units per cubic meter, depending on the panelist who was making the measurement. We have done these measurements inside of the wastewater treatment plant in several points, also close to the area of the complaints, and other point here that is a pumping well that we have presented the work in a poster outside. Also, we have made measurements with polytrons 1000 that have a measuring S2S. They have a measuring range from 1 to 100 ppms, and we have used it mainly to try to measure S2S producing in different sources of the wastewater treatment plant. Also, we have measured this part. This is a wall, a perimeter wall of the wastewater treatment plant, just to see if we have concentration higher than 1 ppm in this part. Here, more or less, the description of the model. We have used our model, as I said before. Just to highlight that we have doing 6,400 points receptor grid with a cell size of 2.5 meters, and we have total length of 200 meters. The meteorological data we have used in this work, because we need very accurate meteorological data for this. We have found it from Valencian Association of Meteorology, that's about Met, and also from a local windsurf club that was Wind Guru, that has a meteorological station. So what we found during our work, this is the first result we have found, that air quality that was made with this polytron show that all measuring points have no measurements below the detection threshold, except the inlet, where we have found concentration up to 50 ppms. In your left, you can see the emission pattern, and you can see that the emissions mainly produced during the afternoon and during the evening. If we see the inlet water to the water treatment plant, this is the pattern of this parameter. You can see that the main part of the flow comes also into the water treatment plant during afternoon and evening. So you can see the correlation that it was pretty mostly the same. So we have found the point where the measurement was produced. And what's this exactly? This is before any action to mitigate the odor. We have found that the inlet of the wastewater plant to the wastewater treatment plant was open air with this fall of water. And here we have venting of the S2S, and this is the origin to complaints. In order to mitigate this problem, we had to do is just to install a rotary screen to avoid solids coming into the reactor, and also submerge the inlet. Here you have the results of photometry measurements. Just to highlight that these photometry measurements corroborate the air quality measurements we did with the polytron. The main concentration we found in the inlet of the reactor, we have shown in the previous part of the presentation, and also in the pumping well that I said to you that is outside in a poster. Also, we can see here that with 20 meters distance, this is the size of the biological reactor, more or less the concentration of odor reduced to values less than 7 odor units per cubic meter. Just to highlight also that we have found in these measurements odor in the street. It was one of the points that close to the resident area. This was caused because traffic. It's not the odor found in this part was not correlated with the odors of the wastewater treatment plant. Another input to the model is the wind pattern. And the study shows that we have here in your left the wind rows. The main part of the time, wind was blowing to the resident area. Here is the wastewater treatment plant. Here is the emission point of the inlet, and here we can see this direction is like contrary. That the wind is blowing directly to this resident part where the complaints were done. Also, we found that the main part of the wind or the wind speed was higher also here during the afternoon and the evening. So this part was very unfavorable to solve the problem with other complaints. Finally, here we have the results of the model. And then we have only 2 timestamps that have S2S concentrations higher than 5 ppbs in the resident area. That's the threshold, odor threshold of this compound. And we need a concentration in the source of the odor higher than 7 ppms, just to find this kind of concentration in the resident area. Also, we have found that after submerging the pipe of the inlet in the wastewater treatment plant, there is no modulation that found or results in concentration higher than 5 ppbs in the resident area. So the problem of odor in this part of the city was solved. Almost the problem is caused by the wastewater treatment plant. So the final conclusion of the work is that the modulation was shown as a useful tool for the odor annoyance management in wastewater treatment plants. I have to remind that this was a little one, so there's not a big budget to solve these kind of problems. There's no perceptible concentrations occurring during the study period, except 2 single events. So more or less, the problem was not very high, but at the end we have solved more or less the problem we found in this installation. And the change in the inlet configuration was effective to reduce concentration of S2S in wastewater treatment plant and surroundings. And field of optometry also corroborate modulation results. Here you have my contact details in case you need more information or would like to know something about this. Thank you.
Thank you very much, Carlos. We are very late, so we have only time for one question, if there is any from the audience. No questions? Well, I have one, very simple. Just a confirmation, because probably I didn't get it completely. The dispersion model was run on the H2S concentration, so it used the H2S concentration as emission data, right? Yes. And the field the data obtained with field olfactometry were used as a comparison. Mm-hmm. Is that correct?
That's correct. Yeah, we use as input to the model the S2S data from the polytron, and also the wind data. Okay. Field olfactometry just to corroborate this data from the model and to see if the problem of odor annoyance was as important as we thought.
Okay. Thank you very much.
Thank you.